This video is a tutorial demonstration of the FracTool plugin, FracTool, implemented in the Abacus CAE interface. The tool is intended for use for early stage designs on part models with existing meshes with only hex elements. The tool will estimate the energy and strength of any defined tensile fracture plane. Here we have an assembly of a propeller blade with its constituent parts. Now, in order to run the estimation, we select the plugin menu item. At the top of the Abacus CAE window, here you will find the FracTool plugin named FracTool. Click on this and the user interface will pop up. On this first tab, you can see all the requirements are in order to run the estimation. The most important thing is to make sure the composite definition is correct for the setup. So for this estimation, I'll be running it for a single blade, for show, in the Abacus CAE window. So if we look at the composite layout, make sure that the regions defined for the layout is the same across all blades, and also make sure the element relative thicknesses add to 1. Also, in this tab, you can see there's a link to this video demonstration as well. On the second tab, you select the part for which you want to perform the estimation. For this demonstration, I'll be using the part named Blade 1 ASSEM. On the third tab, you select which material properties to use. You can either select the material from the database, or you can define a custom material by clicking on the respective radial buttons. For this example, we will use the database material T800S M21. When using the material database, you need to select which length unit to use in order to ensure that material properties are defined constant with the unit used in the Abacus model. For this, we'll use millimeters. Now we are ready to define our desired fracture planes. The tool allows you to define just a single fracture plane, or you can define an axis to sweep multiple fracture planes. In the fifth tab, it gives you the ability to sweep along an axis and estimate the strength and fracture energy of multiple planes normal to their axis. There are 3 ways of defining the axis, first of which is simply by using one of the global axes in Abacus. The second is to define your own axis using 2 points selected from viewport. The third is to define an axis by manually entering the coordinates of 2 points. In order to use the global axis for plane sweeps, first click on the checkbox at the top of the tab. Now click on the global axis radial button. For this demonstration, we'll be using the Z-axis as the sweep axis. The tool also allows you to define the number of planes for which you want to run the analysis. Under the vortex resolution, there's a dialog box with number of potential fracture planes. Enter an integer into the dialog box and then click OK. The analysis will now run and the output will be shown for each plane in the message area. After all the planes are analyzed, the tool will identify which is the critical plane. The tool will also generate plots for the fracture energy and strength for the different positions along the chosen axis. The plots are stored in the Results tab under XY plots, and they will be called Energy Output and Force Output.